Cool. So thanks everyone for attending this meetup for May. For those that are not aware, we do broadcast a live stream to our YouTube channel, which is great. So you'll be able to see that this afternoon. We'll process that as well, so we'll clean it up a little bit. We also take photos for our social media, and we'll put that on Meetup, that sort of thing, and on LinkedIn, Twitter. So if there's anyone a bit camera shy, let us know, because we don't have to use that footage. We can try and remove you out, blur it. We've got the technology there. We'd like to a special thanks as well to my volunteers. Samson's on holiday at the moment, so I'm quite jealous. But we are looking for volunteers as well. So if anyone's interested in helping out your local community, running something, you don't have to have a massive time commitment to the group, but if you fancy coming down once or twice, you get a free t-shirt, so something to consider, and it makes you feel good as well. So if you're interested, reach out. This meetup, we've been doing this meetup for 8 years. We've been 2 years at this venue, and we can't do this without the help from other sponsors and other support. So just a massive thanks to SNA, Hyperloop, JetBrains, and Eagle Labs for supporting us. A few slides from our sponsors. So Lily is the head of Barclays Eagle Labs, so she's works this entire building, and what this is a hotspot for entrepreneurs. So James has worked here today, and I know a few other people have. I think Alex has worked in here, and we've got quite a few people who've worked here. They have a free day, so if you ever want to check out these facilities, booking in a meeting room, you fancy getting out your home life and coming into the office for one day, they offer a free pass. Anything on that you can negotiate with them. It's really good rates, sort of like buy as you need. So if you need anything like that, do speak to Lily. We've also got Alex here as a representative, so if you've not met him already, he's really friendly. Speak out and say hi. He heads up the global recruitment facility at Hyperloop. Recommended if you've ever worked in Liverpool before, he's probably worked with them companies to help hire talent. So if you are in the market, I want to hear anything else about that, speak to Alex and reach out. And we've also got an SNA group who are sponsoring us now. And right here, they offer training packages, and it's really, really interesting. So if you work for a company, you can essentially get free training, free foundational training worth about 14 to 18,000 pounds on average if you was to go and buy that out of your own pocket. How does that work? Well, you can think of companies and the government scheme. The work was to acquire a levy. So when the company pay tax, 5% of that tax gets held into a levy, and that is used for training budgets. So you can actually get training in leadership, business, tech, all for free through this company. And all you've got to do is just reach out and say, it's sometimes the hardest thing they've got is to make it's so good to be true. People don't believe them. So if you are interested and you think your employer would be interested in just literally signing the paperwork, reach out. We can go through that and hear a bit more. JetBrains is another sponsor as well, and you've probably already noticed we've got the scan to win coupon codes. We're going to do a raffle at the end, so you're going to get one of our lucky members is going to get a JetBrain license to give away. Lots of products that you can go away with there. In the case of a fire, just down the stairs, past our great big flag. For those who have not seen it, let me know. We're proud of our flag. And that's it. I'm going to pass you on to James. Thank you.
Find the mouse. Cheers, thank you all. Just do you want to check the live stream's all good first, just to make sure that as I've switched that over, it's still all good. You're all good, perfect. All right, so I want to start with a few questions today, actually, before we get into the content. How many of you have ever had a user come to you and ask that the software you're building was slower than it is today? No one. Okay, cool. Users want things to be fast, right? Users want things to be snappy. Users want things to be performant. Users are never, ever happy. And when you consider that people's job satisfaction, people's job performance is directly tied sometimes to the software that you build. If you've used Salesforce before, you'll know exactly what I mean. Speed is important, right? Second question. How many of you have ever had a user come to you and say, I wish your software worked less well. I wish it brought more often. All right, so for you, how many of you wish you got paged more often? You wish you were on call more often? You wish you were waking up at 3 o'clock in the morning more often? No, still no? Okay, cool. Because we all want software to be safe, right? Users, people using your software, they want the code to work, they want it to do what they expect it to do, and all of you, of course, want any software you write to be safe so that you're not getting paged at silly hours in the morning. Final question. How many times have you ever had someone in leadership in your companies, maybe it's your engineering manager, maybe it's a CTO, someone like that, say, I wish this software cost more money. I wish it was less sustainable. I wish it used more resources. I know it feels like that's what all the AI companies are trying to do at the minute, but we don't actually really want to use resources, do we? I think all of us working in software have a responsibility as engineers, as architects, as technologists to make things as sustainable as possible, right? These are three very contrasting requirements, though, aren't they? And as the great Oprah Winfrey said, you can have it all, you just can't have it all at once. I'm sure many of you have built applications that have prioritized some of these things. Some have needed to be really safe, some have really needed to be really, really fast. Some maybe, in the last couple of years at least, have needed to be really, really cheap to save money. And this is where I think Rust is a perfect partner for these three challenges. Because if you read a lot of the things online, you'll hear that Rust is really performant, Rust is really fast, but of course, I'm sure many of you have read that and thought, well, .NET's fast as well, right? When you're running .NET, it's quite a performant language. But when you combine Rust's speed with its safety, with how much it can do with very, very little memory requirements, very, very little resource requirements, you see that you can actually have all of these three things. Now, of course, there's no possible way I could teach you Rust in about an hour. So what I'll hope you'll all get away from this today is that you'll realize that Rust isn't actually as big and scary as you might think it is. If you read a lot of the stuff online, you'll read that it is a horrible language to learn. The learning curve is incredibly steep. It's really difficult. So that's what I hope you get out of this talk. I'm James Eastham. I'm currently working at Datadog. I'm a developer advocate at Datadog. Don't worry, this is the only dog that will be mentioned in this talk. This is not a talk about Datadog. And have any of you actually used Rust before? Just a quick show of hands. Okay, one hand at the back there. Cool, that's okay. Don't worry, this is okay. We're gonna come at this from a different angle. So I tried to learn Rust for quite a few years, 3 or 4 years ago now. And a lot of the content around Rust is based on systems programming. Rust came from embedded systems, from system programming language, so a lot of the books, a lot of the content is quite low level. It really quickly gets down into the weeds, really, really quickly. Now, for all of us working with .NET and our lovely little abstractions and all these things that we don't really need to worry about anymore, this makes learning Rust seem a little bit of a challenge. And then I came across a really fantastic book called Zero to Production Rust by a guy called Luca Palmieri. And Luca took a very different angle to teaching Rust. He taught Rust from the perspective of building a real application. So throughout the book, you build up bit by bit, piece by piece, an entire application. By the end of it, you've learned Rust. So that's what we're going to do today. We're going to build a user management service. A pretty common use case that you can probably all think about. It'll allow users to log in, users to register, users to generate JWTs, get their user details, update their user details, things like that. And to start, actually, I'm going to say Rust is actually a lot more similar to .NET than you might think. Because Rust has got a really modern, fully featured CLI, where you might be used to running .NET New Console. If you wanted a console app, passing in the name of your app. Rust has a command line called cargo. To start a new project in Rust, you run cargo init. When you run cargo init, you get something that looks a little bit like that in that bottom screenshot. Now, for those of you who remember when .NET applications used to look like that, you used to have a big static void main method in a program.cs file, and that was the entry point of your app. And then Microsoft got rid of all of that to make things easier. In Rust applications always have a main function. The main function is always going to be the entry point of your application. So if you can kind of pretend that top screenshot's got a main function wrapped around it, that's kind of the entry point of your app. Rust also has a really big open source ecosystem, a really big package ecosystem. In Rust, packages are called crates. Instead of running .NET add package, you can run cargo add and then the name of the package. So if you want to work with Azure in .NET, you would add, amongst other things, the Azure core package. In Rust, you would add a reference to the Azure. And then finally, when you want to build your app, you can run .NET publish, or you can run cargo build, passing in the release flag. Pretty similar so far. I mean, I know we've not actually seen any Rust, we've just seen command line flags, right? But It's similar. And then also you can do multi-architecture builds in Rust as well. And multi-architecture builds are a little bit different. So you need to, if you're going to cross-compile, you need to first add the target of the thing that you're going to cross-compile to, which is this little triplet here. So you've got the machine, the processor architecture, ARM64, WASM, x86. You've got the vendor. Now the vendor kind of weirdly is going to be either PC, Apple, or unknown if you're using any variation of Linux. And then finally, the actual OS on the end. That bit on the end tells the compiler what type of file to generate, whether to generate an executable file or to generate a .so file if you're compiling for Linux. And then you've got a project file. Is the contrast on that okay, by the way? Can you all read that all right at the back? Yeah. So you've got project file in .NET. It's got all your metadata, all your dependencies, all that kind of stuff. Same again for Rust. You've got it's all TOML based instead of XML based. Make of that what you will. But you've got TOML at the bottom for defining your app and your dependencies. Pretty similar. Okay. I know what you're all thinking. You're thinking it's basically just like reading .NET. It's also very different to .NET in a lot of ways, I'm sure you can imagine. And something that I hear over and over again when I hear people talking about Rust and why they use Rust is that Rust is boring in production. How many of you have ever dealt with one of them issues where something happens, something breaks in your app, you turn it off, turn it on again, nothing happens for 2 weeks, and then 2 weeks later it happens again, maybe again a couple of days this time, then you get 3 weeks after that and it's really exciting, then it breaks again. Rust is boring in production. Where does this statement come from? This statement comes from, I think, the way that Rust manages memory. The way memory is dealt with inside Rust. And memory safety is really important, right? A whole bunch of security services all over the world published this report back in December 2023. And they all came together and said everybody should be using memory safe programming languages. Now, Rust is an incredibly safe, memory safe language, but it also does that without needing to actually really worry about how the underlying memory gets actually laid out. So let's consider a couple of examples. Some .NET code here, questionable business logic, but just bear with me. So you create a new user object. That user's got an update name method. That method's async for some reason. So you're going to call update name once, call update name twice, wait for both of them tasks to finish, and then print the name. Right? In almost all cases here, you'd expect the name to be Door, wouldn't you? But it might not be. Sometimes it might be John. You just don't know what the end result of this, what the end result of that underlying bit of memory that holds the user's name is. So this is the same code in Rust. Now, don't worry too much about the actual semantics of exactly how this is written. We'll go into that in more detail in a little bit. But again, we're doing the same thing. We're creating a user at the top, giving that user a name. And then we're spawning 2 background threads. We're spawning 2 asynchronous tasks that are both going to update the name, wait for them both to finish, and then print the name to the console. Okay? Which name do we think we're going to get in this one? Do we think we're going to get John? Do we think we're going to get Door? Great question. You're getting none because the compiler is going to complain at you. This is something you get very used to when you start writing Rust. The compiler is really, really angry all the time. What the compiler is saying is that value of borrow of moved value user. Interesting. Right? What does that even mean? And this is the thing that I think causes the most issues as people start learning Rust, is the way that Rust deals with memory management. What Rust calls ownership and borrowing. And Rust uses a really unique approach to memory management, very different to a lot of other languages. In Rust, there is absolutely no garbage collection. And when you think about garbage collection at its core, it's really just a trade-off, isn't it? With garbage collection, you're either collecting often, which means you save memory, use more CPU, or you collect less often, and you use more memory, less CPU. Did I get that right? Yeah, I got that right. And Rust, there's none of this garbage collection. There's none of this memory being sat around until somebody thinks it can be disposed of. Memory management in Rust works by as soon as a variable falls out of scope, at that exact moment in time, the memory is dropped. The value is dropped from memory, should I say. So coming back to our example, what exactly is happening here? So when we spawn that first asynchronous task, we're spawning a background thread to update the name. That thread takes ownership of the user variable. Okay? And then as soon as that thread finishes, that user is going to be dropped from memory. So the error message we saw before where it said the use of moved value user, the user has moved into this background thread. When that background thread completes, the value gets dropped from memory. Which means what the compiler is complaining about is that you're trying to use the value here, or down at the bottom again with the print line, is there's no way you can even guarantee that this value still exists in memory at this moment in time. Now, I realize this is an incredibly trivial example, but this is one of the really powerful features at Rust. At compile time, the compiler is going to track how every single piece of memory moves through your entire application, and anywhere you're doing something that's not memory safe, it's not going to compile your application. It's going to catch it at compile time. This also means because values are dropped from memory as soon as they are not being used anymore, you can do things with incredibly low memory requirements. So how exactly do you get around this? How exactly do you fix this? And this is where the idea of borrowing comes in. Borrowing is another really fundamental difference with Rust. So where we saw in that last example, that thread took ownership of that user variable, right? But of course, there might be scenarios where you want to pass pieces of data around and you don't want the thing you pass it to take ownership of it, because when that scope finishes, the value is going to be dropped from memory. And this is where borrowing comes in. So a slightly different example here, we're going to create a new string and we're going to calculate the length of the string. And you'll notice littered throughout this code, there's this little ampersand symbol. So this tells the compiler that you don't want the thing to take ownership of it, you want to borrow a reference. You can think of this like reference and pointers in .NET. So instead of the calculate length function taking ownership of our variable s, which would then be dropped from memory as soon as that calculate length function returned, we're saying here you can have a reference to the piece of data, but the ownership stays with the main function. So you're being really explicit about who owns a given piece of memory at any moment in time. And if you do anything you shouldn't, the compiler will get angry at you again. So the last difference before we start writing some actual code is mutability. So back to this same example again. So we've got our string s, and then inside the calculate length function, we're going to change the value of s. Why you would do that in a function called calculate length, don't know, but we are doing. So we're going to change the value of s inside that calculate length function. Perfectly valid .NET code, right? Try and compile this in Rust, and Rust is going to say you cannot assign to a mutable argument s. Everything by default in Rust is immutable. Every variable is immutable. If you want to mutate something, you've got to specify that. You've got to say, I'm going to create this string, and this string is a mutable string with that little mute keyword. And when you pass the value to your calculate length function in the signature of the function, you're saying this is I want to receive a reference to a mutable string. And if you tried to pass a variable into that calculate length function that wasn't mutable, guess what? Compiler won't let you do it. And equally, if you create a variable as a mutable variable and never actually change the value of it, the compiler is also going to only give you a warning this time, but you can say, like you can in .NET, treat warnings as errors, and then you can make your code not compile if you declare something as mutable, but it isn't actually mutable. So these are all features to help you write safer code, being really explicit about what you're doing with your memory, you as a developer being really explicit about who exactly owns a piece of memory and what exactly has permissions to change a given piece of memory. Sometimes I like to say Rust is a functional, object-oriented language. It kind of sits somewhere in the middle because you've got some data types that feel a little bit like object-oriented programming, but you've got some of these language features that are a bit closer to functional programming. Confusing thing to say though, isn't it? So let's go and have a look at some actual code now. And I'm going to have to sit down here, sorry, those at the back. And let's do that, and let's do that. And hopefully you can all see that okay. Are we all okay on the live stream now that I've switched screens? Perfect. So let's talk about data types first. Let me get to the right example. I'm in the wrong folder. That's really helpful. Let's try this instead. Zoom it in. So, like many programming languages, Rust has strings. And there's two different ways to declare strings in Rust. You've got this first one here, which is known as a string slice. This is a fixed size string. Its size is known at compile time, and it doesn't get allocated to the heap. So you can think of this, if you're familiar with spans in .NET and span of type T, the string slice works a lot like a span.
So it goes into the stack, yeah.
The other way to declare strings is either using this toString, so you declare your string and then say toString, strangely, or you can say string from hello. And this differently is now heap allocated, and this is a growable string. This is a string that can be modified. You can change the value of. We've got integers, we've got floats. Again, differently to .NET, all numeric values, you typically have to indicate the size of that value when you declare it. So you've got I8, I16, I32, and I64. Same again for the floats. And then you can also use usize and isize, which will just use the size of numeric values in the processor architecture that you're using. So we've got strings, we've got numbers, you've got arrays. Arrays, differently to .NET, are fixed size in Rust, and you have to declare their size at the point of initialization. So we say we've got an array of I32s here. This is of length 3, and we can't change this, we can't add things, we can't take things off. If you are mutating lists of values, you've got this vec data type. Vec, think of it like a list in .NET. You've just got a list of values. We could declare that using that little syntax here. So we've got strings, we've got integers, we've got arrays, we've got booleans. Booleans are easy. And then we come to this idea of immutability. So like I said, everything is immutable by default. If I remove that mute keyword there, I get an error in my IDE because I'm trying to assign to an immutable variable. If I put the mute back in, compiler error goes away. And equally, you've also got this idea of shadowing, where you can have multiple variables with the same name. So I can declare another variable saying this is my new value, and then I can declare another variable, and this is another new value, and this is absolutely fine. Of course, it will always take the order of these statements matter. You can also do this inside a block. So if I just create a random code scope there, set my string example to this is a new value, when it comes back out here, the value will be the same value as the one. Okay. And then we come on to, so we've got all our base data types there. We've got strings, we've got ints, we've got numbers, we've got lists, arrays, booleans, mutability. Then we get on to classes. And I'm going to do this back over here, I think. So to define a class in Rust, you've got this struct data type. A struct can have properties, a collection of values, collection of properties, should I say. When it comes to actually adding methods to a struct, you do that with in a completely separate block. So you see here, I've got this imp block. These are all the implementations for my user struct. Okay, and I've got two here. One is a new function. This is, instead of having constructors, this is the not mandated by the compiler way of initializing a new value of thing. It's kind of an idiomatic way that Rust developers create new instances of things. It's just creating a function called new that returns a new instance of my user. And then we've got this update email address function down at the bottom. And there's a few different ways you can define a function on a struct. The first one there is just fn, the function new, and then we've just got the values we're going to pass into that function. This function's a lot like a static method. So you'd say user colon instead of dot, but user new. Okay? You've then got this next one, which has got this really weird syntax at the start of it that says ampersand mute self. So this self keyword is a keyword where you say, I want to create this function on an instance of my user. So you would create a new instance of your user, then you would be able to say user dot update email address, user dot say hello, user dot update to premium. The difference between the three, the @mute self, is I want to be able to mutate a value on myself. So you've created a new instance of a user. I'm going to call the update email address, and I want to be able to mutate a value on myself. Say hello. I just want a reference to myself. I just want to get a piece of data from myself. Read only, copy. So an ampersand is a reference, and then self, I can get access to all the properties on myself. And then finally, you've got this weird one down at the bottom, which is just self without the ampersand. This is a bit close to, I suppose, like functional programming, where you might want to call this update to premium method. That would then take ownership of self, and it would then dispose of itself. It would then clear itself from memory. Very edge case. There's not really a lot of good use cases for this, but this might be a scenario here where we've got this user object. We want to update that to a premium user, and then we want to dispose of the original user data afterwards. Bit of an edge case, but it does happen. So to go back to structs, structs like classes, structs can have properties, and then you can create your methods on them structures with an implementation block. Now, enums are where things get particularly exciting. And I know you've never heard that before, that enums can be exciting, but enums get particularly exciting, believe me. So this is how you might be used to using enums or doing things with enums in .NET, right? So you've got your user type enum up at the top. You've got a user class, a freemium user class, and a premium user class. The main difference between them three things is in the constructor, the user type gets set to whatever the user type enum is. Now, I realize you could model this with pure inheritance, but by way of example, just bear with me. And in Rust, enums look pretty similar at first. You've got this user enum. You probably mistake that for .NET code, right? Things get a little bit weird because options in enums can have properties. So here we're saying this user enum has got two options, standard and premium. And that option can have a value. It can hold values. It can hold data inside that option. Enums can also have functions. You can call a function on an enum. So you could create a new instance of your user enum, call a function on that user enum, and then inside the actual function, you can then have all your logic to say, what should I do if it's a standard user? What should I do if it's a premium user? The other thing with enums in Rust is that if you have here we're using this match keyword, which is a little bit like a switch with pattern matching in .NET. If you don't handle one of the cases in your enum, the code will not compile. It will make sure you have handled all possible options. If you haven't, you'll get a compiler error at this point as well. So it's really powerful for modeling business logic, modeling business domains. Because if you've got all these different types of state that a thing can be in, maybe you come and add a new state into your enum, all the places in your code where you've used that, your code will then fail to compile unless you've handled that new edge case. Okay. Features built for safety. So let's go and have a look at this. No, that's not right. Where has my ID gone? It's over here, isn't it? There we go. So when where are my enums? They're over there. Module 4. Either's module 1, module 2, module 3, module 4 will all make sense at the end, believe me. So we've got our user enum here. Our user enum has got a standard type and a premium type. Just by way of example, if I add a freemium type, you see I've now got all of these compiler errors because the compiler is saying you've not actually handled the freemium option. And the compiler errors you get are normally really, really useful. You see, it's been really explicit to saying, hey, you're missing part of your match. You're missing this freemium option. It has not been covered. Now, you can, like you can in .NET with the default keyword, you can say, I want to add a default case. In a lot of cases, I would actually recommend not doing that because then you lose this value of you had a new option and your code then stops compiling. And then inside, one of the powerful things about this, let me just clean that up again, is that now from a modeling business logic perspective or from something calling into this user, they don't need to necessarily care about if it's a standard user or a premium user. All that logic is then encapsulated inside this user enum. So when I call this update to premium function, for example, well, if it's already a premium user, we just return ourselves. We just return me because I'm already a premium user. If I'm a standard user, well, then I need to return a new premium user passing across the actual values. Oh yeah, sure, yeah. So enums have superpowers in Rust, particularly when it comes to modeling business logic. As you'll see in a little bit, you can also model errors. So instead of throwing custom exceptions, you would model all of your errors in your application as an enum. And then if you add a new error case, your code does not compile until you've handled that error specifically. So let's actually start thinking about modeling our actual user service now. And if we wanted to model a user API, a web application, first thing you probably want to do is to start working with JSON. All that so far has been pretty low level, right? Kind of internal features of the language, internal things that maybe you use some of them, maybe you don't. So if you're going to build a modern web API, you're probably going to need to use JSON, right? Most modern web apps talk JSON somewhere. And if you're familiar with working with JSON in .NET, you've probably used system text JSON. You've used the JSON serializer class. Create a new instance of your user object and called JSON serializer.serialize. Now, is anyone here familiar with system source-generated serialization in .NET? It was a new feature they added in like .NET 7, I think it was, or 6 maybe. This was like a precursor to native AOT, so source-generated serialization. At compile time, all the code required to do serialization is generated at compile time, which means your serialization, deserialization no longer needs to use reflection, which makes serialization and deserialization faster, for one. The other benefit of this is that, obviously, when they added native AOT, where in native AOT in .NET, you can't use reflection, so source-generated serialization kind of came the version before native AOT. So if you're doing a lot of JSON serialization and deserialization today in your .NET code, definitely go and have a look at source-generated serializers because they can make your code more performant. The reason I bring that up though is because that's how JSON, working with JSON works in Rust. You add an additional package. So the core Rust library, the standard library in Rust is quite lightweight. Most things you want to do in Rust, you need to add a package for. And to work with JSON, you add a package called serde, which is shortened serialization and deserialization and then mashed together into serde. So you add this package called serde. Serde is just like an intermediary, just an abstraction. It has its own internal data structures. And then you add an additional package for the thing that you want to serialize and deserialize into. So you'll see here we're calling this serde_JSON. There's also serde_YAML, serde_toml, serde_avro, serde_message pack. You get the idea. There's a whole bunch of different packages that actually tell serde what to manipulate that value into. And then we call toString pretty, which will then pretty print us a user. And when you try and compile that code, again, as you're getting used to, the compiler gets very, very angry at you, yet again. And this time it's saying the trait-bound user details deserialize is not satisfied. Helpful, right? And if you actually look, if you actually look the first note value, this is what when I was saying that the compiler is normally really helpful with the error messages it gives you. It says for local types, consider adding derive serde deserialize to your user details type. Sounds kind of useful, doesn't it? So as I said, with this using this source, this idea of all the code required to serialize and deserialize is added at compile time. So when you compile your app, everything needed to manipulate values to and from JSON is generated. So if we go and have a look at, no, that's the wrong one. This is the right one. So what this means in any of your structs that you want to be able to manipulate, there we go. So for any values that you want to be able to serialize or deserialize, all you're doing is adding this little annotation here, this little what looks like an attribute in .NET. This is what's known as a macro. I've not got time to go into what macros are. Just think of these like this is generating code on your behalf. So at compile time, this little derive serialize, deserialize tells the compiler at compile time to generate a whole bunch of code behind the scenes. If you only needed to serialize, again, you could just add serialize. If you only needed to deserialize, you can just add deserialize. And all types, so we've got our user type here, which has user details as one of its properties. If user implements serialize and deserialize, but our user details does not, again, the code will not compile because all the types all the way down the stack need to be able to be manipulated to and from whatever data, whatever structure it is that you're working with. And then when it comes to actually working with JSON, you saw that toString pretty function in the slides. And then equally, when I want to convert a value from JSON into a struct, again, I've got this from string function here. So I'm saying Serde JSON from string, and then I get my user details. The big thing to remember with JSON is that you need to make sure you add the serialize and deserialize attributes. That, like I said, this derive is what's called a procedural macro, a declarative macro, a macro, and that's just behind the scenes at compile time, generated a whole lot of code behind the scenes to actually manipulate that JSON, that data into JSON. So we've got JSON now. We've got JSON now. So let's talk about APIs. And we're very, very lucky in the .NET ecosystem. I found this as I've started learning more and more programming languages, that we have ASP.NET or we have ASP.NET. If we're going to build a web app, that's your options, right? You're using ASP.NET, really. In Rust, you've got a framework called Eastham, which is nice, which is pretty good. You've also got Leptos and Actix and Loco and Ruli and Rocket and Poem, and honestly, the list goes on. There are so many web frameworks in the Rust ecosystem you wouldn't even believe. Every time I go to a Rust conference, I feel like there's another company there who are talking about their new web framework that's amazing. So which one do we pick? The second problem we have building a web API is that Rust doesn't have an asynchronous runtime built in. It has support for async await, but inside the core Rust library, there is no asynchronous runtime. And asynchronous programming is kind of useful for things that are I/O heavy, right? When you're building out web APIs, for example. Still, what do we do? So we want to use a web framework, and we've got to pick a web framework, and we also want to use asynchronous code because that's more efficient. We can use our threads and the threads that are available better. And again, like I said before, a lot of things in the Rust ecosystem, you'll need to add a package to do that. And thankfully, there's this package called Tokio. And Tokio gives you the asynchronous runtime. And you probably find yourself, if you are building a business application in Rust, you probably find yourself adding Tokio to almost every single project that you ever have, because it allows you to use async await. And how you enable Tokio is that you've got your main function that we saw earlier, the entry point to all of your Rust applications. To enable the asynchronous runtime, you simply annotate that with another one of these little macros things, these little attributes. At compile time, that's being converted into something that looks like that. All that's doing is starting up the Tokio runtime behind the scenes. And then we can actually start defining our API. So this is everyone familiar with minimal APIs in .NET, by the way? There's people still building with like the controller base, mostly nods. Okay, cool. So a minimal API in .NET, we're going to create a new web application builder. And then further down, we're going to call that app.map_post, and we want to map the /user route to when there's a post request to our /user route. We're going to call the register user method. Yeah. Cool. And I actually think when you start defining APIs in Rust, things start to look pretty similar. So we create a new app, a new router. You could think of this like you're calling your web application.build. So we've got this new router, and then we can add all of our individual routes to that router. So we've got a /users endpoint, a /login endpoint, and a /users their email address endpoint. If there's a post, or a get, respectively, we're then going to call the register user function, the login function, or the get user function. So we're defining APIs in a pretty similar way. We've got this main function. We create a new app. And then we add the individual routes that we want our to be called, passing in the actual functions in our application code we want to be called when that route is invoked. So yeah, we'll go through all that. The last little manual thing that you need to do that is different from .NET is you just need to tell the app where to listen. So in this case, we're saying startup on port 3000 locally, and create serve the application on that port. Last line down at the bottom there. And let's have a look at that. So as we start to flesh out this API a little bit more. Here we're creating a new router. We've got our post endpoint to register the user, and we've got our get endpoint to get the current users. If we go and have a look at this register user function, we're using the Axum framework here, actually. That should have been in the slides. So of all the many frameworks that I put up on screen, we've used Axum. We used Axum because Tokio, which is the asynchronous runtime, Axum is built by Tokio. It's the only reason why I've picked Axum. All the other web frameworks are very, very good. I just thought, well, it kind of makes sense. Let's use the same framework that's built by the people who are building the asynchronous runtime, right? And inside these functions that you pass to your endpoints, there's this whole range of different extractors, they're called. So here we've got a JSON extractor, and this is going to extract the contents of the body into this register user request struct, and we're saying we expect the body to be JSON. That could equally be form if you were passing in form data. There's extractors for query parameters and path parameters. I think it's path for path parameters. Yeah, path parameters. So all your function has is all these extractors, and you're extracting out the various different types of values. The reason I brought up JSON serialization in the last module is that if I delete that deserialize from my register user request, my code, as you might expect, will now no longer compile, because I'm asking it to deserialize the body of the request from JSON into a register user struct. And that register user struct doesn't have the ability to deserialize because I've not added that annotation. So there's a whole bunch of stuff that gets shifted to compile time checking. Should we try and run this and see what happens? Module 5, Rust app. I'll go run. It's now running on port 3000, localhost 3000, users James, which should give me nothing because they're not created a user. So in 100 lines of code, a lot of this is boilerplate that's not actually used from the previous examples. We've got a running API, which I think if you squint quite hard, looks a little bit like .NET. We create a new app, we create our routes, post, get, and then we've got the actual functions that the application calls. Does anybody want a break, by the way? How many of you are familiar with this, by the way, this error? I don't think I've ever done this talk and somebody said, no, I've never seen that before. Object reference not set to the instance of an object. All right, we've all been there, we've all seen it. In Rust, and I suppose .NET tried to tackle this, right? They added this little question mark keyword where you can say this might be a nullable int, and then at least the compiler can warn you and say, hey, this thing might be nullable, you need to check that. You've all seen that bit of functionality with a little question mark. Null does not exist in Rust. There is no null values, which means object reference set to instance of an object is a thing of the past. I should really just end that there, shouldn't I? And just leave you over that. Yeah, that's why you should all go and learn Rust. Yeah, so null does not exist. It just simply doesn't exist. It's not a thing anymore. Which probably makes you all think, how do you model something that doesn't have a value, right? Because you might have a situation where something doesn't have something, but if it's not null, then what is it? So Rust has got a type just for this purpose. And if I think it's in this example, I think So we've got strings, we've got ints, we've got bools, we've got all these other things that I showed you earlier. We've also got this type called option. So I'm saying the age property here of my user details is an option I32, which means it might have a value, it might not have a value. When I come to actually do some work with this, so when I initialize my user details, for example, wow, that's confusing VS Code. When I when I create a new instance of my user, I am setting the age to none. So that option type is just an enum that has some or none as its two values. So I'm creating my user details, I'm saying this user details age is none. If we then go and look at my update age function, I'm setting the age to be some age. So you're modeling the fact that something has a value or doesn't have a value with an enum under the hood. What this actually means, though, is that you need to handle the fact that an age may or may not have a value. You can write one of these match statements, again, like a switch with some pattern matching, and I want to match on the fact that when a user's age has, go away, IntelliSense, some value, I want to print a line saying the age was updated. If I don't handle what happens if there's no value for my user details, my code won't compile. I'm hoping by the end of this, you're all just going to go, the code won't compile. It's going to be great. Until I handle this non-handler in my switch, in my match statement, now my code's happy, my code will compile. Again, features that force you to write safer code. Okay, so dependency injection does get a little bit weird. There's no kind of built-in support for dependency injection, if you will. So you might be familiar with doing something like this in .NET, where you have an iDataAccess interface. You've got your implementation of your iDataAccess interface, which at this stage just stores things in memory. Really safe application that we talked about earlier. And then when we start our application, we're going to register a new singleton or a transient or a scoped service or whatever that is, and we're going to say our iDataAccess is implemented by in-memory data access, right? And there's no real native way to do this in Rust, and there's no real web frameworks that I've seen that really support it. What Rust does have is this idea of, let's talk about traits first, this idea of traits. So a trait in Rust is just like an interface in .NET. It's a different word for it. So we've got a trait in Rust called data access that has got two functions with email address and store. Then when we actually want to implement that trait, that interface for a given type, we again have another one of these blocks, these implementation blocks. And we're saying here we want to implement the data access trait, the data access interface, for our in-memory data access struct. So the syntax there is just the trait for the thing you want to implement it on. And then you get access to actually write the code to implement them. Now, when it comes to actually injecting those values into your actual web application, things do get a little bit weird. Because you've got to do it using this, it's a little bit too zoomed in, I think. Using this so when we created our router earlier, we created this app. If you remember, we added our routes. We're still not on the screen, thank you. We created our app, we created our new router with our /users post, our /users get, and then we've got this with state thing down at the bottom. And this state, with state allows you to pass the same thing to all of your different handlers. You can think of this like creating a singleton. So we're creating a default instance of this shared state, and we're passing that to all of our handlers. In our actual handler then, where previously I just showed you that JSON extractor to extract a value from the body into a register user request, we've also got this state extractor where it's saying, I actually want to, in this function, I want to use the shared state of the application. So as opposed to in .NET, where you might have add singleton, add singleton, add singleton, add singleton over and over again, you would normally model dependency injection in Rust as just a single struct. So you would have a single struct, which is in essence your dependency injection container. You'd have all the different properties on here, you know, my data access, which is of type data access. You might have your event publisher if you're doing some event publishing. You might have a logger, I don't know, whatever you're doing. You'd have all this stuff on this app state. You'd construct an instance of this app state in your main function when your app starts up, and then you'd pass that to all your functions with this with state function. So although dependency injection isn't quite the same, it does have some, maybe I'm stretching there to say some similarities, but you can do a form of dependency injection in Rust as well. So things start to get kind of cool with this safety, the safety of the application when it comes to actually dealing with databases. All familiar with Entity Framework? Yeah, cool. So there isn't really a great ORM like Entity Framework in Rust, but there is this package called SQLX, which adds some really cool features. So whereas you might be familiar with something like this in Entity Framework, you create a class that inherits from DB context. You set up all how your models get created. If you're doing code first migrations, you do all that inside your class. And then you use that inside your application code by passing in an instance of that DB context and then saying context.users in this case, first or default, where the email addresses match. Right? Now, like I say, in Rust, there's not really anything that works like that. Let's do this in the IDE, actually. Yeah, good idea, slides. So I've got my little notebook with all my little notes on. So once we, in Rust, we're going to first add this, that crate I just talked about called SQLX. So we can use that cargo add, the CLI, to add SQLX. This is the library we're going to use for interacting with our SQL databases. There's also a CLI that comes along with that allows you to do database migration. So I can say cargo SQLX migrate, add a new thing, and that's going to create me a new migration for my new thing. Which folder am I in here? Am I in module 6? Yes, I am. Cool. So if I look at my module 6 folder now, I've got this migrations folder and I've got an empty SQL script. I can then write my migration code in here, whatever you think. That was quite helpful, Copilot. Thank you. Then I want to apply my migrations. I can press cargo SQLX migrate run. Of course, to do that, I need a database. And in true Blue Peter style, I've got a Docker compose file somewhere in this repository. There it is, Docker compose -d. Docker's not running, that's helpful. There we go. And if I set this environment variable and I run cargo SQLX migrate run, that's then going to go off and apply my migrations. Where do you reckon I last gave this talk, by the way? And here we've got some actual migrations here. So I created my table called users, and then there's another migration here that doesn't actually have anything in it. And much in the same way as Entity Framework, behind the scenes, this is going to keep track inside your database of what migrations have been applied and what haven't, so it knows if you're partway through exactly where you are up to. Now, where this gets really handy, though, is when it comes to the actual data access code. So although it's not a true ORM in a sense of you can't do like context.users.find and then pass in a link query, it does do an element of type checking. So to give you an example, if I close VS Code for a second, and then I'm going to open a new terminal window. So in this terminal window, I set an environment variable called database URL. It's that environment variable that the application's using to connect to my database, right? I'm just passing in my connection string as an environment variable. So if I open up a new terminal window and I don't set that environment variable, and I navigate into the same folder, source, solutions, code. So now I've just opened up Visual Studio Code, a brand new VS Code window without that environment variable set, okay? And if I go to my data access code now, that's the wrong data access code. This is the right data access code. Data access. When the compiler finishes running, what I should get in here is a whole bunch of compiler errors. Because what SQLX is doing is it's actually in real time type checking against the database with the connection string that you pass in. So if I was to add a new property called that, my code now does not compile because, oh, there we are. So now it's saying set the database URL to be able to type check your SQL queries. So although it's not directly transferring from your structure in your database to an object, to a struct, it is doing an element of type checking against your database. So here it's saying I can't type check because you've not set your database URL, therefore I can't actually compile this application code, because it's saying I can't compile it because I can't check what the structure of the database is. If I just close that, don't save, set my database URL and reopen, and it will also do that a layer deeper. So if I try and insert a property into my database, like that what I just did that doesn't exist, when the compiler actually wakes up, it's going to say, actually, that column doesn't exist in your users table. So it's saying, well, this SQL isn't going to be valid because you're trying to interact with a column in the database that doesn't actually exist. And then, although it's not in my select statement here, I'm selecting a field, a database column called email address, called name, and called password. Although it's not directly type checking, when I get to this data variable down here, which is just the actual row from my database, I can say data.email address, data.name, or data.password, because they're the names of the columns in here. If I was to change that to say hello Liverpool, save, my property down here is then also going to be called hello Liverpool. So although there's not that direct mapping like an ORM would be, there is, again, a whole bunch of type checking that happens at compile time to make sure that you're not doing things that you shouldn't do when you're writing raw SQL queries into your application code. I wonder how this works with SQL injection. I wonder if there's a way we can try and... Sorry, I'm going off on a little tangent now, but I'm just interested. Is that even going to compile? About where, sorry? No, so the hash is in the speech mark hash is like an escape character, so you can do multi-line strings, but good spot. This will be giving me some silly. Oh, so it's expecting it to be a string literal. Okay, yeah, fine. It doesn't let you do it in a roundabout kind of way. Sorry, I was just interested then. I've never thought of that before. So yeah, you pass your variables in as $1, $2, $3, and then you've got positionally 1, 2, 3 in your actual query function. Yeah, and you can also do things like fetch optional. There might be a value, there might be not. Fetch optional then returns that option type that we saw earlier, and obviously this is optionally going to have a value. It also might not, which then forces you to handle the case where something doesn't have a value.
So
that's your null handler, exactly. Yeah, exactly. So you're saying if you were to just call fetch here or fetch 1, and there wasn't a value behind the scenes, that's going to panic. A panic will then just crash your application completely. Yes, but you can't. There's no try catch, so you can't catch it. So if your code panics, code's gone. Yeah, application is dead. But yeah, you could think of it like throwing an exception in. Yeah, in almost all cases, that is a code smell calling panic, because it is just going to crash your application. Full stop. Cool. Where are we? Okay, so the last thing I just wanted to talk about, I think we're right on time here, is everyone's favorite topic. Yay. Every time I spoke at NDC Oslo last week and then at Melbourne a few weeks ago, and there's a bit in the talk where I talk about testing, and I always say, hands up who loves testing. I always get at least one hand. Yes, we've got one hand here. 3 hands. Yes, that's it. I always get a few. I always expect there to be nobody. Nobody puts their hands up, and then there's always a few people. Maybe, yeah, that's a good point, actually, yeah. Yeah, everything works. So unit testing in .NET, any kind of testing, I suppose, we're all quite familiar, right? Whatever testing library you're using, this is XUnit, you annotate your test with the fact attribute, run .NET test, and it knows to actually go off and run the test. And Rust tests are very similar. You've got your function. Here we've got a function called when new user is created should be standard, we annotate it with that little hash test. This tells the compiler that this is a test. So when you run cargo test, like you would run .NET test, it'll actually go and run all your tests. And then you've got that assert equals, or here we're actually going to panic because again, we want this to fail, we want this to error if the test case doesn't pass. But where this actually gets a little bit interesting is how tests actually get structured in Rust, because that's kind of interesting. I think it's module 10. Yes, it is. Cool. So as opposed to in .NET where you might have your application code and you might have a test project separately, in Rust, you would almost always have your tests in the same file as your actual application code. Why would you do that? I don't really like this, maybe controversially, because the code you're testing is in the same place as the tests. So I think this is a nice approach. And then this little flag here, this CFG test, this tells the compiler to only compile this code when not running, or only compile it when there is a test, when you are running a test, sorry. So none of this code is going to be included in your final build. And it just means, again, I can see why people wouldn't like this, but it saves you jumping back and forward between different projects, different files. Everything's just in one place.
You could run it as a separate file.
You absolutely could put it in a separate file, yeah, if you wanted to, 100%. Yeah, you could have a file called core.test.rs if you want. The important bit is the test flag. That's telling it what this function is a test function. This CFG test here is just saying only compile this if it's a test run. Otherwise, don't compile this code. And then we wrap all of it in this mod. This just indicates a module. We wrap all of that in a module just so that we don't have to paste that on top of every single individual function. Right? We're wrapping all of that in a scope and say, don't compile any of this entire module. It's what, sorry? Yeah. Yeah, but a module isn't. A module is more like a library or a package than a class. But yes, same idea. You're putting everything in one place. Yeah. The downside to it, of course, is that you end up with, if you've got a lot of tests, you end up with your code file being 500 lines long because you've got 100 lines of actual code and 500 lines of test in the same project. For your point, again, this example here, it's got an example of unit tests and of integration tests. The integration tests are in a completely separate project with everything just having that test annotation, and there's no actual code at all. If I was to try and cargo build this project, it probably would build, but it'd just be like an empty binary, I think. I don't actually know what that would do, to be honest. So that's testing. So there's a couple of things that I spotted in there. I've tried to run through this quite quickly, sorry. The one last thing, where was it? It was in there. Coming back to enums again, and enums having superpowers. So here we're modeling all of the errors that our application might have as an enum. Yeah. User already exists, user does not exist, incorrect password, getting more and more generic, application error just being like a general exception, I suppose. When it comes to us then writing any kind of data handling logic, not in there, in here, we can match as we are here. So we can match on which endpoint is this? A login endpoint. So we can match if the login was successful, then we want to return an OK status code and some JSON. If the login wasn't successful, then we want to return an unauthorized status code with no JSON. If there was then an actual error, we can then write a match statement on the type of error. So here I'm saying if it's a user does not exist exception, return not found. Otherwise, I've got this catch-all case where I'm just going to return an internal server error. That probably does need to be a little bit more involved. And again, if I delete my match statement, then the code does not compile. So that's a little bit of a whistle-stop tour through Rust. What I've tried to show you there is that it's not actually all that scary. There's web frameworks, there's database libraries, there's SDKs for all of your favorite cloud providers or auth providers, and it's becoming quite a popular language. So most things that you would want to use, most SaaS products, most third parties have got a library available to be able to interact with. And when you're keeping things at this high level, you're building business applications, it's actually a really powerful way to start modeling business logic, to start dealing with errors, to start making your application safer. Also doing all of that with that low memory consumption, that low, because it started life as a systems programming language, these really resource constrained examples, you can do a whole bunch of this with very, very low resource requirements. I did a 2-day workshop last week in Oslo, and there were a couple of people in the workshop who the thing they loved the most is that they could take this back to their organization and say, this will make our applications cheaper. Because when you consider most apps are being priced in the cloud based on how much resources they are using, Rust would allow you to minimize that in almost all cases that I've ever seen. Now, I'm not suggesting you should go and rewrite your whole application infrastructure in Rust, but hopefully it's made you want to give it a try. Now, I've whistle-stopped through all of that, and you saw all the things for like module 1, module 2, module 3, module 4. I did a 2-day workshop in Oslo last week, and it is all publicly available. So there's an entire workshop online. There's a GitHub repo alongside that. This goes through step by step everything I've gone through in an hour today, with a lot more detail, with examples, with challenges. The URL is, I was quite proud of the URL actually, rust4.net. I was quite pleased with that, if I'm honest. But that exists, that's online. If you wanted to work through that, then that's all there to be able to work through if you want. A couple of other examples. If I just go back, I saw people were taking photos. And then again, alongside my online workshop, there's also the book I mentioned at the start. It's genuinely a fantastic book if you're interested in learning Rust, especially because Luca, who wrote it, used to be a .NET developer as well. So he comes at it from a really nice angle. And then he's also, same guy, Luca, has got a website called Rust Exercises. So that was a whistle-stop tour through Rust. I hope that was useful, enjoyable, and I hope you're all encouraged to at least go and give it a try. Thank you.